this session. Today, we shall be talking about appropriation of energy resources. The new energy resources were found by the societies, and the practice of using energy on a larger scale was adopted. The use of energy resources was reliant on the accessibility of the sources of the various forms of energy and their availability. It was also closely tangled to how different societies consumed energy, which was diverse and adjusted to the stratified social structure. Pre-industrial societies have little historical data on their energy supplies, and the same is true of their energy use patterns. Based on this evidence, we will illustrate many types of energy resources and the historical development of the energy pattern consumption. The relationship that specific environmental conditions obtained in India had with the appropriation of energy resources will also be elaborated on in today's lecture. Energy forms. Energy is generally understood to carry meaning as the source of strength necessary for performing various kinds of activities. They can be verified mostly in terms of the work performed with their sport. The word energy is derived from the Greek inertia, which is made up of en, in, and ergon, meaning work. The idea of energy in the above sense goes back to Galileo in the 17th century. He recognized that in lifting weight, the force that was applied was a form of energy. The idea was further developed by Newton by suggesting that the quantum of force applied to an object was associated with the acceleration gained by the object. Natural forms that are inanimate and animate make up of the majority of the energy forms. Both humans and animals use their physical energy to complete tasks. This is animate energy in its most basic form. Similarly, most physical substances contain natural or inorganic sources of energy. They can be found in the primary level as water, wind, and solar energy, and in the secondary level as thermal, mechanical, and chemical energy. Nevertheless, it is difficult to describe all types of energy. Although the energy's source are apparent, the energy itself is transitory and only it generates through the activities. Therefore, in our attempt to identify the forms of energy, we will discuss the source of energy. The source of energy can be broadly divided into two categories, more or less compatible with the two main forms of energy: animate source of energy, inanimate source of energy. Humans have relied on animate source of energy for a very long time in history, except for the energy produced by the sun. Human physical power was considered to be the primary source of energy in the early stages of development. Humans' physical prowess served as the main source of energy throughout all those long years when agriculture had not yet emerged and hunting and gathering activities were the main means of subsistence. The purpose was clearly to target human physical energy and carefully segregate the majority of the work completed for different use of energy to be applied to them. The mechanical spring which stores energy and releases it suddenly when needed may be mentioned also here. Its first known application and ongoing significance were in the bow used to fire arrows in battle and during hunting. North Africa provides the earliest clear evidence of it, which dates to later Paleolithic times. However, the strength of the human arms that would utilize the instrument next, possibly the animal energy limited the effectiveness of the rudimentary bow. The domestication of wild animals represented a significant development in the sphere of energy resource use. Numerous facets of life have used animals as a source of energy. They were significant sources of food for people as well. Animal power was trained to be used in agriculture and drought power. In peninsular India, Neolithic sites showed a high imperative for large numbers of livestock maintenance from their inception. Animals provided the energy for transportation purposes right up until the beginning of mechanized models of haulage, demonstrating how useful animal power had become to agriculturists. The rock drawings at Morhana Pahar near Mirzapur in Uttar Pradesh contains one of the earliest examples of this type of energy harness. Alternatively, an important area where animals supplied energy was in the field of irrigation, water lifting devices. Likewise, the cow also provided cow dung, extensively used to fire the hearth. Humans as well as animal excretion has been extensively used in the fields as fertilizer to increase agricultural production. When early humans discovered the use of fire, they were the first to make controlled use of external, non-living energy source. They used the energy from the biomass for cooking and heating by burning dried plant material and animal waste. Humans relied heavily on the resources of the forest for heating needs. The raw materials from the forest were also widely employed for a variety of other things, including dwellings, the construction of furniture, carts, agricultural tools, musical instruments, and numerous other handicrafts. Wood has been an integral component of human housing since ancient times. Even in mud houses, roofs were usually made of wood. The necessity for wood was greater in the absence of technological support. The demand for forest resources for this kind of activity kept on growing with the increase in the population and material development of human societies. In humans' early attempt to harness inanimate natural forms of energy, water occupies a central position. Besides being a key life-sustaining resource for most living beings, includes humans, the irrigation potential of water for sustaining agriculture has also been discovered fairly early. The first civilization in India, as also elsewhere in the world, was riparian. Water used as an important energy resource was common in the early period as well. The movement of massive tree trunks and logs from one location to another was thought to have been accomplished by the water flowing in significant streams and rivers. But with the advent of a few mechanical innovations that were energy saving, greater utilization of water energy became feasible. Water was probably first used in this way for powering water wheels. The flour mills are still operated with the aid of water wheels today in the hilly regions of India and other countries with terrain similar to these. The majority of the inanimate natural resources was now utilized. The level of exploitation started putting the existence of the majority of the natural resources in danger as the pressure on them progressively increased. Now, coming to energy consumption and historical patterns. It is convenient to claim that change in the rates and patterns of energy consumption have closely followed human social evolution. Early on in the development of human society, both the horizontal and vertical extent of energy consumption was essentially equal. The levels of energy use had been kept to a minimum, and there were very few opportunities to store any surplus. The majority of these societies' energy needs may be met by locally obtainable food. The need for more modern energy sources and the consumption of energy increased along with the development of agriculture on the one hand and the domestication of the animals on the other. The primary source of energy underwent the most significant transformation as manpower was gradually supplanted initially by the strength of draught animals. Donkey-driven mills were used to grind maize in Greece by approximately 300 BC, and they had been used to crush ore from the Laurian silver mines from the 5th century BC. The usage of wind and water energy was the following significant development. Agriculture irrigation was one of the most significant uses of water energy. It has been customary for a long time to supply cultivated areas with water through channels. Early evidence of this kind of irrigation comes from Mesopotamia and dates to around the 7th century BC. The proximity of Tigris and the Euphrates, which guaranteed a steady supply of water, aided with this irrigation. According to Stephen Lloyd, almost the whole of the alluvial plains is capable of being prodigiously fertile agricultural land, and a greater part of it has been under cultivation at one time or another. The extensive network of old irrigation canals that have now been abandoned and whose spoil banks reach far out onto the plain beyond the few farmlands of today is evidence of all this. The evidence from the Harappan settlement suggests that small bunds were erected across the rivers to use the flow of energy of water for spreading fresh alluvial soil along the banks. The soil was then used as an agricultural field. The knowledge of the Harappans about water energy is further supported by the discovery of the famous dockyard at Lothal. It points to the fact that knowledge relating to the tidal currents was tactfully used in creating the dock so that ships could come in with flow tides and could go out into the sea with ebb tides. The very early use of water energy was in driving wheels. The evidence relates to the 2nd or 1st century BC. In Egypt, the wheel was submerged in running water which made it run. This type of mill was used to grinding cereals or oil-producing plants. This was a stage when natural energy and mechanical contrivances were combined. This gave a remarkable boost to the use of energy as it enhanced its driving power substantially. The early water wheels, first used to drive mills for grinding grain, were subsequently adopted to drive sawmills and pumps to provide the bellow action for furnaces and forces to drive tilt hammers or trip hammers for forging iron and to provide direct mechanical power for industrial mills. Until the development of steam power during the Industrial Revolution, water wheels were the primary means of mechanical power production, rivaled only occasionally by windmills. According to Greek geographer Strabo, King Mithridates VI of Pontus in Asia used a hydraulic machine, presumably a water mill, by about 65 BC. Early vertical shaft water mills that drove querns were known in China by the 1st century AD and were used throughout Europe by the end of the 3rd century. The Roman architect and engineer Vitruvius first described a horizontal shaft watermill in about 27 BC. Like watermills, windmills were among the original prime movers that replaced animal muscle as a source of energy. They were used for centuries in various parts of the world, converting the energy of the wind into mechanical energy for grinding grain, pumping water, and draining lowland areas. The earliest known references to wind-driven grain mills found in Arabic writings of the 9th century AD refer to a Persian millwright of AD 644, although windmills may have been used earlier. It is challenging to predict the power output of windmills, just like with watermills. A huge Dutch windmill from the 17th century with a sail span of 100 feet probably produced about 10 horsepower at a wind speed of 20 miles per hour. The experiment conducted by French physicist Denis Papin laid the groundwork for the utilization of steam power. Papin created the first pressure cooker in 1679, a closed container with a tight-fitting lid that contained steam until high pressure was produced. By creating a steam engine in 1765, a Scottish instrument maker named James Watt made it more effective and practical. Michael Faraday's invention of a mechanism that transformed mechanical energy into electric energy was another significant advancement in the use of energy. As a result, thermal energy was employed to drive mechanical energy, which in turn produced electric energy, leading to the invention of electric generators. The ability to transmit energy to locations far from its source has historically been the main benefit of using electric energy. Nuclear energy, which has enormous potential, has been another important energy source. Now, let us talk about the conservation of energy. The concept of energy conservation is related to the theory that energy remains constant and it only changes its form. The conservation of energy is not a description of any process going on in nature, but rather it is a statement that the quantity called energy remains constant regardless of when it's evaluated. The law of conservation of energy can be applied not only to nature but to any isolated system as well. Energy exists in various forms and is convertible to one or another form within the constraints of conservation law. The different forms of energy include thermal, kinetic, gravitational, chemical, nuclear, radiant, electric, mass energy, etc. It is universal applicability of the concept of energy as well as the completeness of the law of its conservation with different forms that make it so attractive and useful. However, one must remember that all the forms of energy are still not in control of humans. Most of the energy we consume has led to an increase in other unwanted or unwarranted form of energy. The most visible example can be uncontrolled consumption of combustion energy that has led to an increase in chemical energy causing ozone depletion. Therefore, it is necessary to realize the spirit of law of conservation of energy and either control over consumption of energy or develop other non-conventional sources of energy. Most of the energy resources consumed by humanity are exhaustible and non-renewable. Therefore, it is necessary to be prudent in one's consumption of finite sources of energy. At the same time, we must realize that there are several renewable sources of energy, and it is suggested to develop the technology to harness the potential that is going waste. Dear students, the assessment of energy resources which has been performed here raises the possibility of a correlation between social stratification and consumption patterns. We can track change in the supply of energy along with change in energy consumption patterns. Plants, animals, and humans themselves had been the primary energy source in the past. People subsequently tapped the inert potential of the land's energy, and soon the potential of numerous minerals as energy sources was as well. With the increase in urbanization, it was observed during the global spread of civilization, the trend of rising energy consumption persisted. As social stratification began to take place during this age, different groups within society used varying amounts of energy. Energy consumption changed vertically throughout the years that followed and up until the start of the Industrial Revolution, but it stayed largely the same horizontally. Since the start of the Industrial Revolution, the pattern of energy consumption has undergone significant changes. Energy sources, as well as the way they are used and distributed, undergo a paradigm shift as a result of the Industrial Revolution. Our environment has significantly deteriorated as a result of the very quick changes that were made during and after the Industrial Revolution. Some signs of the sources changing composition include the destruction of trees and the pollution of water and the air. With this, today's lecture comes to conclusion. See you next. Till then, goodbye and good night.